Hey everyone, this is Mr. W. Our topic today is something called prime numbers. There's actually a lot of prime numbers, but our lesson today is going to focus on the first 6 prime numbers. By the end of this video, you will be able to determine and list the first 6 prime numbers. List the first 6 prime numbers in order from left to right. Okay? First prime number would be 2, 3, 5, 7, 11, and 13. So again, our first 6 prime numbers are 2, 3, 5, 7, 11, and 13. While that seems odd, I'll explain why that's important later. Why are prime numbers important? Prime numbers are building blocks for greater numbers. They're used in the real world. They're helpful to prevent theft of codes like computer codes and passcodes. In math, we use them for prime factoring, which we'll do in a future lesson. And they're very helpful to simplify fractions, which we will also be doing in future lessons. What are prime numbers? All numbers are either prime or composite. I'm going to say that again. All whole numbers are either one of two things. Either they are prime or they are composite. But there is an exception we'll get into, except for 0 and 1. And again, we're talking about whole numbers, not fractions or decimals. Some vocabulary. Let's start with prime numbers. The definition that we're using today for a prime number is a whole number with exactly 2 divisors. One of them has to be 1 and itself, and I'll show you that in a second. We could also just explain that as 2 factors, which really for our lesson, I'm going to focus more on factors. So, for example, 2 is a prime number. That's a fact. Why? Well, let me show you why. The only way to get 2 is if I multiply 1 times 2. You notice that if I list these factors, I see 1 and 2. And remember, our definition is that there are 2 divisors. Remember, that could also be called a divisor because 2 divided by 2 would equal 1, and 2 divided by 1 would equal 2. But in this case, we're using factors, which is kind of like an inverse operation. There are no other factors for 2. For example, you can't say 3 times 2, that would equal 6. And there are no other ways. So that is the reason why. Remember, our definition for a prime number is that you only have how many factors? 2. So 2 is a prime number. 3 is also a prime number. Why? Well, our definition says that it has to be 2 factors. And the only way to get 3 is 1 times 3. If I listed those factors, I would list them as 1 and 3. Remember, back to our definition, one of those factors has to be 1, and you can see that here. 5 is a prime number. Why? Same thing. The only way to get 5 is 1 times 5. If I listed that, our factors would be 1 and 5. Remember, 1, right, according to our definition, and itself. By that we mean Here's 5, and you can see that one of the factors of 5 is 5. That's what we mean when we say itself. Now, there's also something called composite numbers. Remember that if a number is not prime, then it has to be composite. So composite. So if a number is not prime, then it's composite, except for 0 and 1. We'll talk more about that later. The definition for a composite is a whole number with more than 2. Remember, a prime was only 2 divisors, or 2 factors. Composite is more than 2. In this case, we're going to focus on, for our purposes, more than 2 factors. For example, 4 is a composite number. Well, why? Well, 1 times 4 equals 4, but so does 2 times 2. If I had to list my factors, I would list 1, 2. Remember, we only do that one time. And 4. When I count my factors, that's 1, 2, 3. And we said that a composite number has more than 2, and so 3 is more than 2. That's why 4 is a composite number. 6 is a composite number. One times 6 equals 6, but so does 2 times 3 equals 6. If I listed my factors, I'd get 1, 2, 3, and 6. Notice that we have 1, 2, 3, 4 factors, and that is more than 2. Therefore, it is a composite number. Same thing with 8. 8 is a composite number. That's a fact. Why? Well, 1 times 8 equals 8, but so does 2 times 4. If I were to list my factors, 1, 2, 4, 8, I have 1, 2, 3, 4 factors, and we said that a composite number must have more than 2 factors. Some important ideas with prime numbers and prime and composite. Remember again that all whole numbers, meaning that not a fraction, right, or a decimal, all whole numbers are either prime or composite except 0 and 1. So let's talk about that just for a second. 0 and 1 are neither prime or composite. They're kind of like oddball numbers. They're not prime, but they're also not composite, so they're kind of odd. Let's see. Let's see why. Let's check 0. Remember, we said that a prime number has only 2 factors. Well, let's try that. Let's try 0 times 1 equals 0. And you could argue, you say, well, 0 and 1 would be 2 factors, right? Here's the problem with that. I could also say that 0 times 2 equals 0. And really, 0 times 3 equals 0. And I could really keep going. In fact, I could go on forever. So that would be a lot more than 2 factors. So 0 is not prime. Now, is 0 composite? Because the definition of composite is you can say, well, Mr. W, this is a lot more than 2, and that is true. But according to math, a composite numbers, even though it is more than 2, it has to be finite, meaning that there's a limit. 0, the numbers are infinite, meaning that you could be writing these numbers into the millions and billions and trillions and whatever is beyond that forever for the rest of your life, and it would still equal 0. That's what we mean by infinite. So therefore, it is not, 0 is not prime. draw like a frown face, and it is not composite. How about 1? Well, to be prime, it would have to have only 2. 1 times 1 equals 1. Well, we could argue and say, well, isn't that 2 factors? No, remember that when we list our factors, if they're the same, we only list it like that. So we only have 1 factor, not 2. Is 1 a composite number? No, because we have only 1 factor. And remember, our definition of composite is more than 2. Well, that is not more than 2. Let's try some. Solve. Is 7 a prime or a composite number? Well, let's find out. 1 times 7 equals 7. Are there any other ways to get 7? No, 7 is an odd number. We can't use a 2. We cannot use 3 because 3 times any number. So let's write how many factors. I'm seeing 1 and 7. There are only 2 factors, and by definition, this would have to be a prime number because a prime number has only 1, 2 factors. Solve. Is 9 a prime or a composite number? Well, let's find out. 1 times 9 equals 9. But is there another way to make 9? Well, 9 is odd. We cannot use 2, but how about 3? Yes, if we multiply 3 times 3, that also equals 9. There is no other way to get 9, but if we count and write our factors, we have 1, 3. Remember in a previous lesson, we say we don't write that twice. We just write that 1 time. And then 9. Notice that we have 1, 2, 3 factors. Well, that's more than 2, so it's not going to be a prime number. So that would be a composite because a composite number has more than 2 factors, and you can see that here. Solve. Prime or composite numbers. Well, let's look at 10. 1 times 10 equals 10. But can we get 10 another way? 10 is an even number, so yes. 2 times 5 also equals 10. That gives us 1, 2, 3, 4 factors. By definition, that's more than 2, so I'm going to put a big old X for composite. How about 11? 1 times 11 is equal to 11. Is there any other way? Can't use 2. Can't use 3, 4, 5. So there is no other way. So I'm only looking at 1, 2. Remember, the definition of a prime number is only 2 factors. So 11 is a prime number. 12. 1 times 12 equals 12. But so does 2 times 6, and so does 3. I'm counting 1, 2, 3, 4, 5, 6 factors. That is definitely more than 2. That is a composite number. And finally, 13. Well, the only way that I can get 13 is 1 times itself, right? Which is 1, 2 factors. That would put us in the prime number category. Now, the question is that some young people have is it, well, does it just even odd, even odd? And the answer to that question is no. Remember earlier on the first page, we said that 2 is a prime number because it has only 2 factors. And notice that 2 is an even number. So don't be tricked into thinking that it's only even numbers. Prime numbers have only 2 factors. Composite has more than 2. All right. Here is your final exam, right? If you want to pause and test yourself, circle the prime numbers. So if you feel like it, pause. But if you didn't pause, I'm going to circle the prime numbers. I know it's not 0 or 1 because that's neither prime or composite, but my prime numbers are 2, 3, 5, 7, 11, and 13. All of those are called prime numbers. Why? Because all of those numbers have only 2 factors, and we showed that on the previous pages. All right, second question of your final exam, right? List the first 6 prime numbers. List just means to write. The first 6 prime numbers from left to right. If you want to pause and try it, you can. Now, yes, it's kind of cheating. It's really just that, right? But if I want to make it a little bit more challenging and scooch that off the page. Okay, our first 6, it's not going to be 0, it's not going to be 1, but 2, 3, 5, 7, 11, and 13 would be your first 6 prime numbers. Again, in closing, the importance of the first 6, and there are more, but this will be very helpful when we do prime factoring in a lesson that's coming up, and also when we want to use strategies to simplify fractions. Most of the fractions we do will not go over factoring it down to 13. So if you know these by memory, this will be really, really helpful. Okay, real quick, in review today, our lesson was on prime numbers. We focused on only the first 6, which are 2, 3, 5, 7, 11, and 13. You probably want to memorize that. We talked about why it's important. We said that prime numbers have only 2 factors. The other kind of numbers are called composite numbers. Composite numbers have more than 2 factors. Okay, gave you a lot to think about today. Thanks, everybody, and we will see you next lesson.